So we often think of Bitcoin as just digital cash.
Yeah, pretty much. That's the common view.
But get this, the very foundation, the rules that let Bitcoin work have quietly evolved. And now they're enabling things like, well, unique digital collectibles, even new ways to manage ownership right there on the blockchain.
It's kind of like taking a classic car, keeping the look, but putting a modern high-performance engine inside.
Exactly. Unlocking stuff you never thought it could do. Today, we're taking a deep dive into that engine upgrade, Bitcoin's Taproot.
Taproot, activated back in November 2021. And it really was the most significant change to Bitcoin's core rules since, what, SegWit in 2017?
Yeah, quite a while. Now look, if talk about protocol upgrades usually makes your eyes glaze over.
Happens to the Festivus.
Right. Think of Taproot more like a crucial behind-the-scenes improvement, something that ultimately benefits pretty much everyone using Bitcoin, even if you don't see it directly.
Absolutely. Understanding Taproot isn't really about needing to be a crypto genius.
Not at all.
It's more about seeing how these changes can actually improve your privacy when you use Bitcoin, and how they make the whole network run a bit smoother, more efficiently.
And how they open up these surprising new possibilities we're starting to see. So our mission today is pretty straightforward. Cut through the jargon, really get a handle on what Taproot is.
The problems it was trying to fix.
Yeah, how they actually pulled off implementing it, and crucially, some of those unexpected results that are playing out now.
And we've dug into the technical proposals, the BIPs, analyses of its impact, even the debates around it, to kind of distill it down.
Okay, so let's get right to it. Why? Why did Bitcoin actually need an upgrade like Taproot? What were the shortcomings it aimed to tackle?
Right, good place to start. So before Taproot, if you wanted to do something a bit more complex than just sending Bitcoin from A to B.
Like needing multiple people to approve a payment, a company account maybe?
Exactly. Or setting specific conditions like funds can only be spent after a certain date or only by a specific person under certain circumstances. Bitcoin used a system called pay-to-script hash, P2SH.
P2SH. Okay.
Think of P2SH like writing down all the possible rules for spending some money in a very public notebook.
All of them. Even the ones you don't end up using.
Yep. So when someone actually spent those Bitcoins, the transaction had to reveal every single potential rule that could have been used.
Ah, I see. So even if you only used one simple condition out of, say, 5 complex ones.
All 5 conditions got broadcast onto the blockchain for everyone to see.
Okay, that doesn't sound great for privacy.
Not ideal, no. P2SH gave you that power for complex rules, which was good, but the trade-off was transparency. Everyone could see the complexity of your setup.
And I'm guessing putting all that data on the blockchain wasn't very efficient either.
You got it. Bigger transactions, more data to store and transmit across the network. Less efficient.
So privacy leak and bigger transactions. What was Taproot's fix?
Taproot brought in something really clever called MAST. It stands for Merkleized Abstract Syntax Trees.
Okay, MEST. Sounds technical. Break it down.
Think of it like a family tree, but for spending conditions. All the different ways the money could be spent are arranged in this tree structure.
Right.
But here's the key part. Instead of revealing the entire tree when you spend the money, like P2SH did,
You only show
the specific branch, the specific path down the tree that corresponds to the condition you actually used.
Ah, okay, that makes sense. So if you have that complex setup, only the rule you actually follow gets revealed.
Exactly. Everything else stays hidden. It makes your complex transactions look much more like simple, standard ones on the surface.
Which is a massive win for privacy,
It's
obviously.
huge.
Yeah.
Because you're only revealing a small piece of data, not the whole rule book.
And the transactions are smaller and more efficient, too. Less data clogging up the network.
Precisely. Better privacy, better efficiency for complex spending. That's MAST.
Okay, that covers the spending rules. What about the authorization? The signatures? You mentioned multi-sig earlier.
Right. So before Taproot, Bitcoin relied on something called ECDSA signatures, elliptic curve digital signature algorithm.
Rolls off the tongue.
Yeah. For a standard one person sending to another transaction, ECDSA works just fine. No issues there.
But for multi-sig, that shared business account example.
That's where it got a bit clunky. With ECDSA, each person involved in that multi-sig setup had to provide their own separate digital signature.
So if it was 3 people needed to sign,
You'd see 3 distinct signatures attached to that transaction on the blockchain.
which again reveals information, right? It flags it as a multi-sig transaction and tells you how many signers there were.
Exactly. Not great for privacy. Plus, multiple signatures mean, again, larger transaction sizes, more data.
Okay, sensing a theme here. So Taproot must have addressed this too.
It did, with Schnorr signatures. This was another core part of the upgrade introduced in BIP 340.
Schnorr. Okay, what's special about Schnorr?
Well, Schnorr signatures have some really neat properties. The big one is signature aggregation.
Aggregation, meaning
We can take multiple Schnorr signatures, say, from our 3-person business account, and mathematically combine them into a single signature.
Wait, really? So 3 signatures become 1?
Yep, and this combined signature looks exactly the same and is the same size as a standard single Schnorr signature from just one person.
Whoa. Okay, that's huge.
It really is. Suddenly, your 3-person multi-sig transaction looks completely indistinguishable from a simple everyday payment on the blockchain.
That's incredible for privacy. Nobody can tell it's multi-sig just by looking at it.
Exactly. Massive privacy boost. And because one signature is smaller than 3,
it's more efficient too. Smaller transaction size, less network load, especially for complex setups.
right, it just makes those advanced uses of Bitcoin look and feel like normal ones. Smoother, more private.
You mentioned Schnorr came in BIP 340. Any other benefits?
Yes, actually. Schnorr signatures are also known for their provable security based on simpler assumptions, and they fix an old annoyance with ECDSA called signature malleability.
Malleability? What was that?
Basically, with ECDSA, someone could slightly tweak a signature before a transaction was confirmed in a block without invalidating it. This didn't change who sent what to whom, but it did change the transaction's unique ID, the TX ID.
And why was that a problem?
It could cause confusion, especially for services like exchanges that rely on those TX IDs. In some cases, it could even be exploited. Schnorr signatures aren't malleable like that. They prevent that entire issue.
Okay, so Schnorr brings aggregation for privacy and efficiency, plus it fixes malleability. Seems like a clear win.
Definitely, it was a major cryptographic upgrade.
So we've got MAS for privacy and spending rules, Schnorr for privacy and efficiency and signatures. What about the actual capabilities, the smart contract side of Bitcoin, if you can call it that?
Yeah, it's important to remember Bitcoin script, its programming language, is intentionally limited compared to something like Ethereum. Security is paramount.
Right, keep it simple, keep it secure.
But even within those limits, the pre-Taproot Bitcoin script had some constraints. There were limits on how big a script could be the actual code defining the spending rules.
Like a maximum file size?
Sort of, yeah.
Yeah.
A 10,000 byte limit, and also a limit on the number of operations, or opcodes. You could use 201 opcodes max.
Which could hinder more complex logic, I imagine.
It could. It made building more sophisticated things, even within Bitcoin's conservative model, quite tricky sometimes.
So Taproot addressed this with Tapscript.
Exactly. Tapscript came in via BIP 342. It brought more flexibility. One really important change was decoupling script versioning.
Decoupling meaning?
It basically separated the rules for how scripts work from the main Bitcoin consensus rules. This makes it much easier to introduce future upgrades or changes to the scripting language via soft forks without needing a huge, potentially disruptive network-wide change each time.
Ah, makes future evolution easier. Smart.
Very much so. Tapscript also got rid of some of those old limits. The 10,000 byte script size limit is gone for Taproot spends, same for the 201 opcode limit.
Opening the door for more complex possibilities.
Right. Richer logic, more expressive conditions. It also included some specific improvements, like making OP check multi-sig, the multi-signature opcode, work better within Tapscript.
Okay, so Taproot seems like this comprehensive package. Better privacy with Amez, better privacy and efficiency with Schnorr, and more flexible scripting with Tapscript. Sounds great on paper, but implementing something like this across a massive decentralized network like Bitcoin, that sounds like a monumental challenge. What hurdles did they face?
Oh, absolutely. It was a huge undertaking. First off, just the switch to Schnorr signatures was a major cryptographic engineering effort.
Rewriting the core signature code.
Pretty much.
Yeah.
The fundamental crypto libraries in Bitcoin Core, the main software client, had to be carefully rewritten, tested, and optimized for Schnorr.
And you have to make sure it's secure, obviously.
Paramount. Secure, compatible with everything else, and performant. Remember, Bitcoin nodes run on all sorts of hardware, from powerful servers to, like, Raspberry Pis. The new code had to work efficiently everywhere.
It really is like doing that engine swap on the plane while it's flying, isn't it?
Yeah, that's a good analogy. You cannot just stop the network. Which brings us to the second huge challenge.
Yeah.
Backward compatibility.
The soft fork aspect, making sure older nodes don't break.
Precisely. Taproot was a soft fork. That means nodes that didn't upgrade still needed to see Taproot transactions as valid, even if they couldn't fully understand or enforce all the new rules themselves.
How do you even do that?
Very carefully. It involves clever tricks, like making the new pay-to-taproot outputs, P2TR outputs they're called, look like a specific type of existing SegWit output, version 1 SegWit outputs, to older nodes. They see it as something they can validate, even though the real magic is hidden inside.
Wow, that sounds incredibly fragile.
It requires meticulous design and exhaustive testing. A mistake here could be catastrophic, potentially splitting the network if old nodes and new nodes started disagreeing on which transactions are valid.
High stakes.
Extremely high stakes.
Okay, so you've got the core software challenge, the backward compatibility nightmare. What else? The ecosystem, wallets, exchanges.
Exactly. You can upgrade the protocol, but it's not much use if nobody can actually use it. All the wallets, the exchanges, the hardware security devices, everything needed to be updated to understand and create these new P2TR addresses and transactions.
And that takes time, right? Everyone has their own development cycles.
It does. Adoption wasn't instantaneous. Wallets needed to add support for sending to and receiving from Taproot addresses. Exchanges needed to enable withdrawals to these new addresses. It was a gradual rollout across the ecosystem.
Is it fully adopted now in 2025?
Largely, yes, but you might still find some older services or wallets that haven't fully integrated it. The transition is definitely still ongoing in the long tail of the ecosystem. It takes time for everyone to catch up.
So, a complex technical upgrade needed careful implementation, broad ecosystem support. How did the community actually agree to do it? How did the governance and activation work? I remember the SegWit activation was tense.
That's putting it mildly. Yeah, the SegWit activation debates were quite divisive, and there was a strong desire in the community to avoid a repeat of that.
Learning from the past.
Hopefully. So the technical side was handled through those Bitcoin improvement proposals, the BIPs. BIP 340 for Schnorr, 341 for Taproots, 342 for Tapscript.
And these were debated publicly.
Extensively, on the Bitcoin dev mailing list, primarily. Developers worldwide scrutinized the proposals, suggested changes, raised concerns. It's a very open peer review process. Plus, tons of testing within Bitcoin Core itself.
Okay, so the tech gets hammered out. Then the big question. How do you flip the switch? How do you activate it on the live network?
Right. That was the crucial governance part. There are different ideas like maybe a user-activated soft fork, UASF, similar to what helped push SegWit through.
But that could be confrontational again.
Exactly. So the consensus landed on a method called speedy trial.
Speedy trial.
Okay.
Sounds efficient.
The idea was to give Bitcoin miners a clear, limited window, 3 months, specifically to signal their readiness for the upgrade.
How do they signal?
By setting a specific bit in the blocks they mined. If, during a specific 2-week difficulty adjustment period within that 3-month window, 90% or more of the blocks mined showed this signal.
Then it was locked in.
Yep, locked in, with activation scheduled for a specific block height a few months later. If the 90% threshold wasn't met within the 3 months, the activation attempt would fail, and the community would have had to go back to the drawing board.
So it put the onus on miners to show broad consensus quickly.
Right. And thankfully, unlike the SegWit saga,
It worked.
it worked smoothly.
Yeah.
The 90% threshold was reached quite comfortably within the signaling period.
Q.
And Taproot activated at block 709632 in November 2021, pretty much without any drama or major controversy. It was seen as a testament to the broad agreement that had built up around the benefits of the upgrade.
That's great to hear. A quiet, successful, major upgrade. So it's been live for, 3.5 years now? What are we seeing in terms of its long-term impact on Bitcoin?
Well, let's start with that privacy promise. Are complex transactions actually looking simpler?
Yeah, is that potential being realized?
It's definitely starting to. We're seeing tools and protocols emerge that really leverage Schnorr signature aggregation. Things like Music2 and research into Frost. These are protocols that make multi-signature setups even more practical and private.
Making multi-sig indistinguishable from single-sig.
Increasingly so, yes.
Yeah.
As these tools get integrated into wallets and services, that initial promise of Taproot closing those privacy leaks for complex transactions is becoming a reality. It lays the foundation for even more advanced privacy techniques down the line, too.
Okay, privacy getting a boost. What about the smart contract side? That increased flexibility from Tapscript. Are we seeing radically new things being built on Bitcoin?
It's maybe more subtle than radically new compared to, say, Ethereum's capabilities. Bitcoin's approach remains conservative.
Security first.
Always. But Tapscript is open doors. There's a lot more research and development happening now around concepts like covenants.
Covenants, like
Yeah,
rules about future spending.
exactly. Ways to put constraints on how a Bitcoin can be spent not just now, but in subsequent transactions. Think about enforcing specific spending policies, or creating secure vaults where funds have built-in withdrawal delays or require multiple steps to access.
Interesting. So enhancing security and control.
Potentially, yes. Proposals like CTV, Check Template Verify, and APO, any pre-vout, are exploring this space. It's still mostly in the R&D phase, getting debated and refined. But Taproot provided the necessary scripting upgrades to even make these ideas feasible to discuss seriously for Bitcoin.
So enabling future possibilities there. Now, let's talk about the elephant in the room, maybe, the unexpected consequence.
Mm.
Inscriptions and ordinals.
Yes. The curveball.
How did Taproot, an upgrade focused on privacy and efficiency for monetary transactions, end up fueling this Bitcoin NFT movement? It seems counterintuitive.
It really does. And it's
Yeah.
fascinating. It boils down to how Taproot structures transaction data, specifically the witness data.
The part with the signatures and scripts?
Right. Taproot made the witness structure more flexible. And crucially, the discounts applied to witness data, introduced back with SegWit, made putting data there relatively cheaper than in the main transaction body.
Okay.
And Tapscript, by removing those old script size limits, combined with the MST structure, well, it inadvertently created a loophole or perhaps an unforeseen feature.
Which was?
It became possible and relatively economical to embed significant amounts of arbitrary data like images, text, even code directly into the witness part of a Bitcoin transaction, specifically within the Taproot script paths.
So you could kind of hide data inside the spending condition possibilities.
Essentially, yes. You create a Taproot output where one spending path involves revealing this chunk of data. Ordinals protocol then built a system on top of this to number individual satoshis and inscribe them with this data stored on-chain via Taproot transactions.
Wow. So an upgrade designed for efficient, private payments, accidentally enabled storing JPEGs on Bitcoin.
Pretty much. It leverages the witness data structure and Tapscript flexibility
Right.
in a way that, frankly, few predicted would become so popular.
And this has definitely sparked debate, hasn't it? Blockchain bloat versus innovation.
Oh, absolutely.
Ah.
A very lively debate. Some argue it's congesting the network with non-financial data and driving up fees. Others see it as a legitimate new use case demonstrating Bitcoin's flexibility, enabled, ironically, by Taproot.
It's a classic example of unintended consequences in complex systems.
Couldn't have said it better. It really shows how foundational changes can ripple outwards in unexpected ways. Taproot structure was the key enabler here.
Okay, so looking beyond privacy enhancements and the inscriptions phenomenon, what's the bigger picture for Taproot's legacy? How does it set up Bitcoin for the future?
I think one of the most significant, maybe underappreciated long-term impacts is how it makes future upgrades easier.
How so?
That script versioning change we talked about, decoupling script rules from consensus rules, is huge. It means introducing new opcodes, new signature types, or other scripting improvements can potentially be done more smoothly as soft forks in the future.
Making Bitcoin more adaptable.
Exactly. Taproot's output structure is also more modular. It provides a cleaner foundation. We could see things like even more advanced threshold signature schemes like Frost being integrated, or cross-input signature aggregation to combine signatures across multiple inputs in a transaction for even greater efficiency.
Maybe even bigger changes down the line.
Potentially. There's research into things like entirely new, more powerful scripting languages like Simplicity or those covenant proposals we mentioned. Taproot makes the pathway to potentially implementing such things, if the community decides to, much clearer and less disruptive than it would have been before.
So it's not just about the immediate benefits, but about future-proofing Bitcoin's evolution.
That's a great way to put it. It provided a more flexible, adaptable base layer.
Okay, so if we try and wrap this up, Taproot wasn't really one of those flashy, headline-grabbing crypto events.
No, definitely more of a quiet, behind-the-scenes, deeply technical upgrade.
But despite that light profile, it sounds like it's fundamentally reshaped Bitcoin's foundations.
I think that's fair to say. It tackled some deep-seated issues in Bitcoin's cryptography with Schnorr, its scripting limitations with Tapscript, and its privacy shortcomings with MAST and signature aggregation. It created a more robust, more versatile, and more private base layer.
And its full impact seems like it's still playing out, right?
Yeah.
We're seeing the privacy tools emerge, the inscription debate is ongoing, the path for future upgrades is clearer.
Exactly. It wasn't an endpoint. It was a crucial step that enables continued evolution, hopefully in a way that maintains Bitcoin's core properties without breaking things.
Which really leaves you wondering, given how Taproot has already enabled things people didn't foresee,
Hmm.
what other surprising capabilities might emerge on Bitcoin in the next few years, building on this foundation that maybe we can't even imagine right now?
That's the million-dollar question, isn't it? Or perhaps the multi-billion Satoshi question. It definitely keeps things interesting.
It certainly does. Well, if this deep dive into Taproot sparked your interest, you can definitely go explore the BIPs themselves, 340, 341, 342, or dig into the whole ordinals and inscriptions topic. Lots more detail out there.
For sure. Plenty to explore.
Thanks for joining us for this deep dive.